Hi everyone, welcome to State of AGI webinar. Today we are going to cover a very interesting topic, which is artificial general intelligence, or AGI. What we are trying to do in this one is to provide some definition of AGI, also the current state of that, what's actually are happening in this space, and also the future state of AGI. So this is the agenda for this webinar. So we're gonna start with the AGI definition. So we will start by defining the AGI and how it differs from what we call it as a narrow AI. And also we are going to cover the current state where we currently stand in the AGI development. We will also cover some of the approaches that are used to design AGI, and then we will discuss where the field is heading, including international collaboration and also the importance of the safety and governance in this space. All right, let's talk about the definition. So AGI stands for Artificial General Intelligence, which is designed for a specific task like recommending movie or recognizing faces. These are what we call it as a narrow AI, which is just honest like a specific task. But then AGI is system that can think, learn, and adapt across a wide range of tasks like a human. The key idea is general adaptability. And AGI would not just excel at one thing, it would be capable of handling anything from solving a math problem to writing a story or even learning new language, all without needing to be retrained for each task. It's important to note that AGI is still a theoretical goal. As of 2025, we haven't developed a system that truly meets this definition. Our researchers are actually working on that, but we are not there yet. So to understand AGI, it's important to compare it with what we have already. So narrow AI. Narrow AI refers to systems that are really good at a specific task, like playing chess, recognizing images, translating language, and so on. These systems perform within a limited scope and can easily adapt beyond, they cannot easily adapt beyond what they were trained to do. AGI, on the other hand, aims to do much more. It's designed to perform any intellectual task a human can do. With the ability to adapt to these new situations, even one it wasn't explicitly programmed for. Think of it as a flexible human-like intelligence that can switch between tasks and domain effortlessly. The ultimate goal of AGI is to match or even surpass human cognitive abilities across the board, not just in one area, but all of them at once. While narrow AI is all around us today, AGI remains the long-term vision for the future. So there are several perspectives on what exactly AGI should be, and each field brings actually a different lens to this discussion. From the computer science viewpoint, intelligence is often defined as the ability to achieve goals. This aligns with how AI is typically built, focusing on solving problems efficiently, regardless of how human the process looks. The psychological view adds another layer. It focuses more on adaptability and survival, qualities that define human intelligence. From this angle, AGI should not just solve problems, but also learn from experience and also adjust to unfamiliar situations, much like what we do. Then there is this philosophical debate. Some argue that AGI should replicate human cognition as close as possible, while others believe that true AGI would actually go beyond human capabilities. So even the definition of what we are aiming for is not universally agreed upon. So now let's talk about the current state of AGI. So the research landscape actually is broad and global. A 2020 survey found 72 active AGI projects spread across 37 countries, showing strong international interest in this field. The number has likely grown since, reflecting how serious this goal is being pursued. Recent advancement, especially LLMs, chat GPTs, and so on and so forth, shows surprising versatility and have a spark debate about whether we are inching closer to AGI. But with the progress comes serious experts like Jeffrey Hinton have voiced warn about moving too fast without fully understanding the risk. The concern isn't just about whether we can build AGI, but whether we are ready for the consequences if we do. Despite the excitement, it's important to stay grounded. As of now, AI system is universally recognized as having achieved general intelligence. So in terms of timeline, there is a wide range of opinion on when or even if AGI will be achieved. Some argue that it's already here in early forms. They point to advanced language model and claim we are seeing the beginning of general intelligence, even if it is still narrow in some ways. Others are more optimistic but place AGI just around the corner. For instance, Dario and others predict we could see AGI emerge as early as 2026. Looking further ahead, many experts take a more cautious view. Survey often suggests 50% chance of AGI arriving between 2040 and 2061, reflecting uncertainty, but also believe that it's plausible within our lifetime. Then there are some skeptics who believe AGI might never happen at all. They argue that we may run into fundamental limitation, whether technical, psychological, or even biological, that prevents machine from truly matching human intelligence. So one of the most well-known optimists in the AGI space is Ray Kurzweil. He predicts that AGI could arrive as soon as 2029. His confidence is rooted in the idea of exponential growth in computing power and AI capabilities. Kurzweil also take it a step further with his prediction of the technological singularity by 2045. This is the point where AI would not only match but far surpass human intelligence, triggering rapid and irreversible change in society. These predictions are grounded in the idea of accelerating returns, the belief that technological progress does not move in a straight line but accelerates over time. If this holds true, the development seems far off today might arrive much sooner than expected. Why some are optimistic, many experts remain skeptical about AGI, both in terms of possibility and also timeline. One key concern is the idea of fundamental limitation. Critics argue that current AI method, no matter how advanced, might never scale up to true general intelligence. They point to missing elements like common sense reasoning, or which humans use effortlessly but AI struggle with. So there's also growing timeline skepticism. Many researchers believe AGI is still a decade away at best, and some suggest it might not happen at all, especially if you're missing some core ingredients in how intelligence really works. That leads into the conscious question. There is an ongoing debate about whether true intelligence requires consciousness or subjective experience. If it does, the AGI might not just be a technical challenge, it could be something fundamentally beyond what machine can achieve. So we already covered some of these numbers. So as I mentioned, back in 2022, there was a global survey identified 72 active AGI projects across 37 countries. So expert actually, the prediction, the median estimate for when we might achieve AGI falls around 2040. And also some futuristics like Ray Kurzweil offer a more ambitious prediction, suggesting AGI could arrive as early as 2029. So several major tech companies are at the forefront of AGI. So we have OpenAI, which is perhaps the most well-known one. Their stated mission is to ensure AGI benefit all of humanity. Google is also a major player through DeepMind and Google Brain. Their focus include areas like reasoning, planning, and reinforcement learning. Meta also entered the AGI race. Their research emphasizes developing systems with more human-like cognitive abilities, aiming toward what they call full general intelligence. Microsoft also is a key investor in this space, and mostly through its deep partnership with OpenAI. So let's quickly touch on some of these companies' approaches. So OpenAI take a unique and mission-driven approach to AGI development centered around the idea of creating beneficial AGI, ensuring that when AGI arrives, it serves the interest of all humanity. A major part of this effort involves safety research. OpenAI is investing heavily in studying how to align AGI with human values and also to prevent misuse and unintended consequences. Also, OpenAI emphasizes broad distribution. They've committed to sharing the benefit of AGI widely, so its impact is global and also equitable. Google DeepMind has also made some of the most high-profile advances in AI, especially in the area relevant to AGI. One major milestone was AlphaGo, the first AI to defeat a world champion Go player. This achievement showcased DeepMind's ability to build systems that go beyond brute force and begin to exhibit strategic reasoning. Beyond games, DeepMind has tackled scientific challenges. Standout example is AlphaFold, which made a breakthrough in predicting protein structure, something that had stumped researchers for decades. DeepMind's ongoing focus is on reasoning and planning, key trail of general intelligence. And with the merger of DeepMind and Google Brain, Google has unified its AI research teams to accelerate progress toward AGI under one coordinated effort. In terms of Meta, they actually made it clear that AGI is a major long-term goal. They've openly stated that their ambition is to build full general intelligence. Their research emphasizes developing cognitive abilities in machine, including memory, perception, learning, and problem solving. The goal is to create an AI that does not perform tasks, but actually understand and adapt in a more human-like way. Meta also promotes open research. They've committed to publishing much of their work and open sourcing some of their AI model. Also, let's talk about Anthropic, which is a relatively new but influential player in AGI research. So it was founded by former OpenAI researcher who wanted to place the stronger emphasis on AI safety. Their flagship product is Cloud, an AI assistant designed from the ground up with safety and alignment. Anthropic also takes a research-driven approach, especially in areas like adaptability, trying to understand how AI systems make decisions. They received $18.2 billion in funding, highlighting strong investor confidence in their mission to develop safe, beneficial AGI. Anthropic. So now let's talk about the designing approach. There are several key approaches researchers use to build AGI. So first is symbolic AI, which uses logic and symbols to represent knowledge. This approach excels at structured reasoning, like solving puzzles or following rules, but it struggles with learning from raw data. Then we have the connectionist approach, which includes neural network and deep learning. These systems are inspired by the human brain and have been behind recent breakthroughs in AI. They are great at pattern recognition, but less transparent in how they reach conclusion. Cognitive architectures aims to model the way humans think and learn, trying to replicate the general processes behind our intelligence. This system often integrate memory, learning, and problem solving. And finally, the hybrid approach. These combine symbolic reasoning with neural network, merging structure with adaptability to build systems that can reason and learn flexibility. Many believe these may be the key to achieve true AGI. So in terms of the learning to build a truly general intelligence, AGI system need to learn in flexible and efficient way. So there are like several main learning methods which are central to this goal. So we have reinforcement learning, that in this method AI learns through trial and error, receiving rewards or penalties based on its action. Next, we have unsupervised learning, where AI identify pattern in data without label example. This is very crucial for generalization, especially in situations where labeled data is unavailable. We have also transfer learning, which allow AI to apply what it's learned in one area to a completely new domain. And finally, we have meta learning, or learning to learn, focusing on enabling AI to pick up new tasks quickly, often with minimal data. And this is actually the cornerstone of AGI promise. So let's talk about some of these different learning approaches. So symbolic AI, which is one of the oldest and most foundational approaches to artificial intelligence. It's a logic base, meaning it uses formal rules and symbols to represent knowledge and make decisions. A major strength of symbolic AI is the emphasis on explicit reasoning. Because the rules are clearly defined, the decision-making process is transparent and explainable, which is especially important in fields where understanding why an AI made a choice matters. This approach also relies heavily on knowledge representation, organization information in a structured, symbolic format like decision trees. This allows systems to reason about relationships and facts in a human understandable way. Symbolic AI domain dominate early AI research, especially in the mid to late 20th centuries, before the rise of neural network. Today, it still plays a key role, especially in hybrid AGI system that aims to combine structure with learning. So the neural network approach is the backbone of today's most advanced AI system. At its core is deep learning, which uses multiple layers of artificial neurons to detect and process complex patterns in data. This method is brain-inspired, mimicking how biological neuron fires and connect in the human brain. While it's not a perfect replica, it captures the idea of learning from experience through data exposure. A great example of this action is LLMs like GPT. This system uses massive neural networks to process and generate human-like language, and their performance has sparked serious conversation about how close we might be to general intelligence. So many researchers also believe the path to AGI will require a hybrid approach, combining the strength of different AI methods to build more capable systems. One key example is neuro-symbolic AI, which merges neural network with symbolic reasoning. This approach blends the learning power of deep learning with the structure and explainability of logic-based system, creating model that can both learn from data and also reason about it. Another strategy is modular architecture. Here, different components specialized in various tasks like perception, memory, or planning work together to simulate broader intelligence. This mirrors how different parts of the human brain handle different cognitive functions. Lastly, we have integrated learning, which means combining multiple learning methods like reinforcement learning, supervised learning, and meta learning within a single system. This helps the AI to adapt more flexibly to diverse tasks and environments, a key goal in building general intelligence. Also, cognitive architecture take a different route toward AGI by trying to model how the human mind works. The idea is to replicate general intelligence by mimicking the structure of human cognitive. Example like ACT-R and SOAR are designed a structure framework that integrate key mental processes such as perception, memory, learning, and decision making. These systems aim to simulate not just task performance, but also the underlying mechanism behind intelligence behavior. By grounding AI in human-like thinking patterns, cognitive architecture helps researchers explore how general intelligence might emerge, not just from data, but from how the data is processed and used over time. Now let's talk about the reinforcement learning, which is another powerful method for training AI. So a well-known example is AlphaGo, which mastered the game of Go at a superhuman level using reinforcement learning. It learned by playing millions of games, constantly refining its strategy through trial and error. In robotics, RL allow physical system to learn complex tasks like walking, picking up object, or navigating new environment. RL is also valuable in decision-making scenarios. It helps AI choose optimal action in complex dynamic environment, whether it's managing resources, playing games, or coordinating system. All of this is driven by reward system, where AI receives positive or negative feedback based on the action. These signals guide learning and encourage behavior that leads to desired outcome. So to achieve true AGI, we need a wide range of human-like abilities. It's not just task performance, but deeper cognition. First is common sense reasoning, the ability to understand everyday situation even when not explicitly programmed. It's what allowed humans to navigate the world, and it remains a major challenge for AI. Next is emotional intelligence. AGI will need to recognize and respond to human emotion also, which is essential for building trust, communicate effectively, and also function in social context. Adaptability is also crucial, and a true general system should be able to take knowledge from one area and apply it to unfamiliar situation without needing to be retrained. There is also creativity, which is the ability to generate new, valuable idea or solution. This goes beyond following patterns and requiring think in novel way. Finally, self-improvement. An AGI should be able to reflect, learn from its own experience, and enhance its own capability independently and also continuously. So building those capabilities also include a number of challenges. One major challenge is general reasoning. Current AI is good at a specific task, but AGI needs to reason across domain and connecting concept and applying logic in diverse situations. There is also knowledge transfer. Human can take what they learn in one area and apply it elsewhere, like using problem solving from chess to make a strategic decision in business. So enabling AI to do the same remains a significant hurdle. Long-term memory is also another tough problem. AGI systems need a way to store and retrieve experience effectively over time, not just process information in a moment, but also pass knowledge and to inform future action. And finally, there is computational efficiency. The goal is to achieve human-like intelligence without requiring massive amounts of computation power. Making AGI practical means it must be resource efficient and not just powerful. One of the more ambitious actually path to AGI is whole brain emulation, the idea of creating a complete functional digital copy of a human brain. The goal is to scan a biological brain in enough detail to model every neuron and connection, then simulate that structure in software. In theory, this could replicate human-level intelligence by copying the exact working of the brain. But the technical hurdles are massive. Current technologies simply cannot scan brains at the resolution and scale required. Even if we could, the computer power needed to simulate a brain in real time is still theoretical. Plus, our understanding of brain function, how thoughts, memories, and consciousness emerge, is far from complete. Without the foundational knowledge, full brain emulation remains more of a long-term vision than an immediate path to AGI. As we move closer to AGI, ensuring safety becomes just as important as making technical progress. A core challenge is the alignment problem, making sure AGI systems pursue goals that are truly aligned with human value. Next are control methods. We need a reliable way to guide, constrain, and monitor AGI behavior, especially as it becomes more autonomous and capable. These include everything from kill switches to incentive structure. Ethical frameworks are also essential. Just like we have ethic in medicine or law, we need clear principles to guide how AGI is designed, trained, and used, especially when it may impact society on a global scale. Finally, we need strong security measures to prevent misuse. This includes guarding against bad actors, unintentional errors, or systems that behave in ways we cannot yet predict. So, if developed safely, AGI could transform nearly every area of human life. In healthcare, AGI could revolutionize everything from medical research to diagnosis, personalized treatment planning. In climate science, AGI could help us model complex environmental system, predict long-term impact, and develop more effective, sustainable solutions. AGI could also accelerate scientific discovery across discipline, acting as a research partner that generates insight, form hypotheses, and also even design experiment. In education, AGI could offer personalized learning tailored to individual student needs, helping people learn more effectively. Now, key milestone. So reaching AGI is not a single leap, it's a series of milestones. First is advanced reasoning. AGI must be able to solve novel problems across different domains, not just repeat patterns from training data. Next is efficient learning. Unlike current AI, which often needs massive data sets, AGI should learn from just a few examples. Another critical step is general adaptability. AGI should apply knowledge learned in one context to complete new unfamiliar situation. And finally, we have full autonomy. This means system is not just reacting to instruction, but can set its own goal, learn independently, and also improve itself, marking the true arrival of general intelligence. So for the last slide, let's talk about the future AGI. We are seeing expanding research effort around the world, with growing investment from both academia and also industry. This progress is supported by global collaboration as researchers and institutions across countries come together to tackle the technical, ethical, and also social challenge that AGI presents. There's also huge breakthrough potential. AGI could dramatically expand our understanding of intelligence and also unlock advances in science, medicine, and technology. At the same time, evolving governance is crucial. As we get closer to AGI, we need strong frameworks in place to guide the development, ensuring its use in a safe, ethical manner. Awesome. That was my last slide, and I hope you enjoy it. And thank you for joining us.